Hello and welcome to another exam paper walkthrough. Thank you for joining me today. Today I'm going to be concentrating on the GCSE AQA predicted topic papers. I'm calling this paper paper 2, paper 3 very likely. These are the topics that I think are most likely to be on paper 2 or paper 3. It's difficult to say which one of the two. They're both calculator paper. Attached to the description to this video, you'll find a link to a Google Drive where you can download a copy of the paper. I would strongly recommend you've either done the paper before watching the video or do it alongside the video, just to get the most out of it and maximize your revision. I'd also recommend a bit of music on in the background. Whenever I record these, I like some music on. So this is preparation for the June 25, and I've used the topic list that First Class Maths produced. If you've not checked out First Class Maths, I would strongly recommend you steer a bit of time to give them some revision. I know they've written some predicted topic papers as well. If you like this video, please do subscribe if you like, and you'll get any notifications as soon as any of my other videos become available. So like I said, this is the very likely paper. So First Class Math broke their topics down into 5-star, 4-star, 3-star, and so on. I've produced two papers on the back of that. I've produced a very likely paper based on their 5-star and 4-star questions. I've called it a very likely paper. And I've produced their 3-star questions into a good chance paper. Right, let's get on with the paper. Okay. So question 1, use Pythagoras' theorem to work out the value of x. So I'm going to jump straight to saying that x is going to be equal to the square root of the two sides added together and squared. So 17.2 squared plus 12.9 squared. Right, let's bring our calculator in. If you're using a different model to this calculator, it's not a big deal at all. And I'll talk about anything that I use that's slightly different. It should have all these buttons on yours as well. So 12.9 squared, double check I've typed everything in right. Yeah. Okay, so we're looking at 21.5. So 21.5. Okay, question 2. Harry and Ginny each bought a printer and a hard drive. Here's some information about how much they paid. So Harry's printer and hard drive and Ginny's printer and hard drive. Guinea says, in total, I paid more than Harry because 20% is greater than 10%. Is she correct? Tick your box. So let's work out. So Harry paid a total of 105. Add those two values together. Right, let's work out Guineas. So we're going to do 80, 90%. 10% less than Harry would be 90, so that's a multiplier of 0.9 plus 20% more, so plus 25 times by 1.2 for a 20% increase. 80 times by 0.9 plus 25 times by 1.2 gives us £102. Is she correct? No, she paid less. And the reason being is that 10% of 80 is obviously greater than 20% of 25. Show calculations to support your answer. Okay, so I did my calculations here. We'll do it again though. So I did 80, well, I did two steps really. I did 80 plus 25. 80 plus 25 is equal to 105. So did 80 times by 0.9 plus 25 times by 1.2, and that equaled 102. Right, question 3. On the grid, draw an enlargement of the triangle with a scale factor of a half. So a scale factor of a half means that the shape actually becomes half as big. We haven't got a center of rotation, so we're after a base length of 2. This vertice is above the midpoint by 6 squares, so it will go to 3 squares. So that's going to be our enlargement. Question 4. Hermione drives 198 miles. Her average speed for the first 3 hours at 45 was 45 miles per hour. Her average speed for the rest of the journey was 13.5 miles per hour. Work out her average speed for the whole journey. Right, I'm going to split this into, whenever I'm doing a compound measure question, I quite like to do it like this. So we've got part 1 of the journey, part 2 of the journey, and the total. Distance times speed. Right, so 198 miles is the total distance. Her average speed for the first 3 hours, so time of 3 hours, was 45 miles per hour. Her average speed for the rest of the journey was 31.5 miles per hour. Right, so the first thing I'm going to do then is, I'll change pen just to make this clear. So that's just the information from the question. So the distance that she travelled would be 3 times 45, so 135. And we know that the total distance is 198, so 198 minus that answer gives us 63. So we can work out the time here, which is quite nice. It's going to be 2. But time is equal to distance divided by speed, so 63 divided by 31.5, which I'm fairly sure is 2. Yeah. So that means that her total time for the journey is 5. So her speed for the journey is going to be distance divided by time, so 198 divided by 5, which gives us 39.6 miles per hour. Right, question 5. Luna's total annual salary, annual pay is equal to salary plus bonus. Work out the percentage change in her total annual pay. State whether this is an increase or a decrease. Okay, so last year, we'll start with her total for last year is going to be equal to 26,000 plus 400. 26,000 plus 4,000, sorry. Which is going to be 30,000. Right, so this year, 6% increase is a multiplier of 1.06. 9% decrease would be a multiplier of 0.91. So if we do 26,000 times by 1.06 plus 4,000 by 0.91, that'll give us our total for this year. So 26,000 times by 1.06 plus 4,000 times by 0.91 gives us a total of 31,200. Right, the percentage change in her total annual salary. So it's obviously going to be an increase. To work out our total for the increase, though, you can do the change, so we could do 1,200. I'm going to work it out as a percentage that will be bigger than 100. So I'm going to take this second salary, divide it by the initial salary, and then times by 100. And I'm going to get 100 and something, which will represent a whatever percentage increase. So if we divide that by 30,000 and then times by 100, that gives us 104%. So that's a 4% increase. Right, question 6. Bellatrix wants to borrow £6,000 and repay it with interest after 2 years. She sees 2 offers for loans. Offer 1, compound interest for 3% per year. Offer 2, compound interest. First year 1%, second year 5%. Beatrix says, I will pay back the same amount because the average of 1 and 5 is 3. Is she correct? You must show your working. So for this question, particularly for higher tier, this starting wage, this starting amount is irrelevant. We can just look at the multiplier. So for offer one, regardless of whatever the starting point was, would be times in by compound interest of 3% would be a multiplier of 1.03. So 1.03, and then that's to the power 2 because it's 2 years. I'll do offer 2 at the same time. So offer 2 in a similar vein is going to be x times by 1% for the first year would be a multiplier of 1.01. 5% for the second year would be a multiplier of 1.05. So times by 1.01 times by 1.05. So for the first one, it's going to be x times by 1.03 squared gives us 1.090609. And for the second one, it gives us a multiplier of 1.01 times by 1.05 gives us a multiplier very similar but slightly different, 1.0605. So is she correct? No. And then which one's bigger? This one is bigger. 1.0609. Technically, we don't need to say which one's bigger. We just need to say that they're not different, not the same. So technically, we only need to say that they're different, but that's absolutely fine. Right, question 7. The universal set is 29 students in a class. C is students who own a cat. D is students who own a dog. C, D. A student is chosen at random. Circle the probability that the student owns a cat or a dog, but not both. So that's that one and that one. So that's going to be 12 out of the 29. So we're looking for 12 out of 29. Oh, sorry. Part B. A student who owns a dog is chosen at random. So student who owns a dog, let's change the pen. So we know that they own a dog. So we're looking at out of 15. Circle the probability that the student also owns a cat. So it's going to be 8 out of 15. So that one. Question 8. Dobby owes an amount of £600. He wants to pay this back in 5 months. He says, each month I will pay back 20% of the amount I still owe. Show working to check if his method is correct. Now, if he's paying back 20% of the amount I still owe, we can treat this as a compound interest question. So if he pays back 20% of the amount that he still owes, so let's look at how much he pays back. So we're going to say that 600 times by 20% as 20% means we'll keep track of what he has left. So if he's paying back 20% each time, if we do that to the power of 5, that will tell us how much he's paid back. So 600 times by 0.8 to the power of 5. Right, so that's what he's still got left to pay. No, he's still £196.61 left to pay. Right, question 9. The first two cube numbers are 1 and 8. Show that the third cube number can be written as the sum of 3 different prime numbers. Okay, so the third cube number is 3 cubed, which is going to be 27. Right, so 3 cube numbers that add together to make, three prime numbers that add together to make 27. We can't use 2 because if you think about it, 2 would leave an odd number left to add, and 2 is the only even prime number. So you can't have two odd numbers that add. You can't have two prime numbers that add together to make an odd because it's going to be an odd and an odd, which must equal an even. So we can't use 2. So let's assume that let's start by assuming 3 will be our next one. If we think about 3, the next prime number would be 5. So 3 plus 5 is 8, so we'd still need to add on 19, so that would work. It's not going to be the only one. Let's imagine it's not 5, let's see about 7. That would leave us with 17, so that would work as well. What else could we say? Can we say 11? We could say 11 and 14, 13. So those would work. And I think that's it. If we imagine having a 5 here, yeah, that would work because those are the next consecutive prime numbers in effect: 5, 7, 11, 13, 17, 19. So those are going to be the only 3 possible combinations. Right, question 10. Here is a sketch of a graph. So we've got a reciprocal graph. Circle the equation of the graph, that would be that one. Question 11. 180 runners start a marathon. Some of the runners did not complete it. The histogram represents the times of the runners who did complete the marathon. So we've got frequency density and we've got time. How many runners did not complete the marathon? Okay, so we need to do frequency density times by class width. So if we do 20 times by, that would be, if we're going up in 0.1, no, each square is going up by 0.1. So that would be 0.6, 0.7, 0.8. 20 times by 0.8 plus, this is 20 again. The frequency density would be 1.8 plus, this group is 40. Then this frequency density is 1.123, 1.3. Sorry, 1.1 to 1.2. So let's catch up this on our calculations. 20 times by 1.8 plus 40 times by 1.2 plus, again, 40 times by 0.5, 0.6, 0.7 plus, so catch that up, 40 times by 0.7 plus, and then this final group is 20, 40, 60 times by, that value is 0.4. So that gives us 152 that finished the race. The race was out of 180 people. So we're going to do 180 minus 152. So that's going to give us 180 minus answer 28. So 28 did not finish the race. Right, part B. The table shows information about the runners who did not complete the marathon. Least distance, 5 miles, greatest interquartile range, greatest distance, lower quartile, median. Draw a box plot to represent this data. So least was 5. Let's put what we can put in directly. Greatest distance, 23. So we're going up in 2 squares would represent 1. So 23 is going to be here. Lower quartile is 11. Median is 18. The interquartile range is 9. So we've put those directly in. We've not got the upper quartile, but that's going to be quartile plus 11 is going to be 20. Okay, so that's going to be our box plot. Question 12. Neville owns a sandwich shop. The shop is open Monday to Saturday. In June, Neville sold 3,000 sandwiches. Neville wants to work out the mean number of sandwiches he sold per day in June. His method is 3,000 divided by 30 is equal to 100. Make one criticism of Neville's method. Okay, so my criticism here is the sandwich shop wasn't open for 30 days. If it's only open from Monday to Saturday, it's not open on a Sunday. So they wouldn't be divided by 30. So his shop not open for 30 days. It's not open on a Sunday. Okay, part B. Neville received 6,660 from selling the 3,000 sandwiches in June. The number of sandwiches sold were in the ratio of meat to cheese to vegan, 9 to 4 to 6. The price of a meat sandwich was £2.39. The price of a cheese sandwich is £1.89. Work out the price of a vegan sandwich. Okay, right, so meat to cheese to vegan in the ratio of 9 to 4 to 7. So first of all, we want to find the numbers. So that is simplified ratio. So we actually want the actual number. Then we'll talk about the price. Not the, yeah, we'll put the price in. We'll talk about the made, amount made. Right, so we want to start by splitting 3,000 into this ratio. So the ratio parts total 20. So 9 plus 4 plus 7 would be 20, which means that each part is worth £150. 150. So 150 times by 9 would give us 1,350 meat sandwiches, times by 4 would give us 600 cheese sandwich, and then times by 7 would give us the, was it vegan or vegetable? Vegan. 1,050. So we know the price for meat is £2.39. We know the price for cheese is £1.89, but we don't know the other. But we can work out the money made. So if we start 1,350 times by £2.39, that means that he's made £3,226.50 from selling meat sandwiches. 600 times by 1.89 gives us a total for selling cheese sandwiches of £1,134, which means we can work out the amount that he's made from cheese by doing those two added together. Two out there, 3226.5. So that's the total that he's made from selling meat and cheese, £4,360.50, which means the amount that he's made from selling cheese is going to be 6,660 minus that. So we've made £2,299.50, and if each one is priced, if he sold 1,050, if we divide that by 1,050, we get £2.19. So £2.19 is going to be his price for selling the vegan sandwiches. Okay then, right, question 13. Y is inversely proportional to root x. Y is equal to 4 when x is equal to 9. Work out an equation connecting y and x. So if y is inversely proportional, it means y is equal to k over root x. So y times by root x is going to be equal to k. We've got this as our initial situation. So 4 times by root 9 is going to be equal to k. So 4 times 3, so 12 is equal. So that means then our equation is y is equal to 12 over root x. Work out the value of y when x is equal to 25. So y would be equal to 12 divided by the square root of 25, which would be 12 divided by 5, which would be 2 and 2/5. 2.4. Question, yeah, we'll go 2.4. 2 and 2/5 would be absolutely fine there. Right, question 25. Here is some information about the age of people at a concert. Draw a histogram to represent this information. Okay, so we're going to add a few bits here. We're going to add the class width. So I'm going to add it on here. So we'll do it. Just a bit lazy. I don't like drawing two columns. So I'm going to put it here. So the class width here is going to be 5. The class width here is going to be 10. Class width here is 15. Class width here is 30. So the frequency density is frequency divided by class width. So 8 divided by 5, and we're going to go decimal for these. So we're looking at 1.6 here. 24 divided by 10 is going to be 2.4. 30 divided by 15 is going to be 1.5. Oh, no, it's not. It's going to be 2. And then 39 divided by 30 is going to be 1.3. Right, now I need to draw that in my chart. So 10 to 15 is going to have a frequency of 1.6. So we're going up in 2s again. Bring the ruler in. Try and get it semi-accurate. Oh, that might not work. .4, which is going to be here. Was 10. We've then got 25 to 40, and that width is 2. And then our final group is 40 to 70, and that group is 1.3, which would be here. So let's just check my totals. 1.6 for 5, yep. 2.4 for 10, yep. 2 for 15, I've drawn that at the wrong place. And then finally 1.3 for 30. There we go. That's my completed. Question 15. The nth sequence of the nth term of two linear sequences A and B are added together to give the nth term of a new sequence. The new sequence starts. The nth term of sequence A is n plus 1. Work out the nth term of sequence 2. Right, so I'm going to take the sequence given in the question, and from it I'm going to subtract n plus 1. So sequence A, n plus 1 would give us 2, 3, 4, 5. So the difference, or sequence B, is going to be this, take away this, so 6, 10, 14, 18. So this sequence has got a constant difference of 4, so it's going to be a 4n, and then we need to add 2 to get to the first term. Right, question 16. To be rented, a bedroom must have a floor area of at least 6.51 meters squared. A bedroom has a rectangular floor. The floor measures 2.4 by 2.9. Each correct to 2 significant figures. Show that the bedroom can be rented. Okay, so I'm going to take the minimum value of each of them and work out the area, because it needs to be at least. So if we're looking at 2.4, the smallest value that could be would be 2.35. And then the smallest that the second dimension could be would be 2.85. And then provided that area is less than 2.51, we're good to go. So 2.35 multiplied by 2.85 is going to give us a value of 6.6975. Show that the bedroom can be rented, so as 6.6975 meters squared is greater than 6.51 meters squared. Right, question 17. D is directly proportional to the square of V. D is equal to 60 when V is equal to 20. Work out an equation connecting D and V. Okay, so D is going to be equal to K directly proportional times by V squared, or KV squared. So K is going to be equal to D divided by V squared. Right, D is equal to 6 when V is equal to 20. So we're going to end up with not a very nice value for K. Well, it'll simplify a bit. So 6 over 20 squared is going to give us 3 over 200. So that means that our equation is going to be equal to so that means our equation then is going to be D is equal to, I'll leave it as a fraction, so we'll say 3 V squared over 200. Can't go decimal there, I think that'd be 0.15. 0.015, yeah. I'll work out the value of D when V is equal to 30. So then D would be equal to 3 times by 30 squared over 200. So we just need to times that by 30 squared. So that's 27 over 2, which we will do as a decimal, 13.5. Okay, question 18. 727 is a point on the graph y is equal to f of x. Circle the point which must be on the graph of y is equal to f of x plus 2. So this will be a translation in the y-axis of 2. So we're looking for the point 2 bigger than our y value. So that would be 730. Right, question 19. The length of a roll of ribbon is 30 meters, correct to the nearest half meter. Piece of length 5.8 meters, correct to the nearest 10 centimeters, is cut from the roll. Work out the maximum possible length of ribbon. Right, so to do this, we want to take the maximum value that the ribbon could be. So if we call this one X and we call this one Y for now. So we want the max for X and we want to subtract the minimum for Y. So if it is 30 meters, correct to the nearest half meter, the most that could be would be halfway between 30 and 35. No, that's not right. Halfway between. So let's look at this in a slight bit more detail. So 30 to the nearest half meter. So it's been rounded to 30 as opposed to 29.5. So the minimum, wrong way round. It's been rounded to 30 as opposed to 30.5. So the maximum value would be 30.25. And the minimum value, to the nearest 10 centimeters, it's been rounded to 5.8 as opposed to 5.7. So 5.7 to 5.8. The minimum value is going to be 5.75. So what we want to do is 30.25 minus 5.75. So 30.25 minus 5.75 gives us 24.5. Right, question 20. P and Q are points. The x-coordinate of Q is more than the x-coordinate of P. The y-coordinate of Q is less than the y-coordinate of P. Work out the gradient of the straight line through x and y. So if I say that point P is at xy, so that Q is at x-coordinate is 5 more than the x-coordinate of P, so that would be x plus 4. And the y-coordinate is 5 less, so that would be y minus 5. Right, so the gradient is going to be the difference in y divided by the difference in x. So if we do it this way around, this one take away this one, so that would be y minus 5 minus y over x plus 4 minus x, and that's going to give us the y's and the x cancel here, so it would be minus 5 over 4. 5 over 4. Right, question 21. Line A has the equation y is equal to ax plus minus 1, passes through the point 7, 13. Line B has the equation 5y minus 3x is equal to 4. Show that line A has a greater gradient than line B. Okay, so if we start with line A and we're going to work out the gradient of line A, so we're going to use y is equal to ax minus 1, and we're going to say that it passes through the point 7, 13. So x is 7 when y is 13, so 13 is equal to 7a minus 1. Add 1 to both sides, 14 is equal to 7a. Divide both sides by 7, 2 is equal to a. So line A has a gradient of 2. Right, I'll change pen just to show that I'm now moving on to line B. So line B has the equation of 5y minus 3x is equal to 4. So if we add 3y to both sides, 5y is going to be equal to 3x 4. If we divide both sides by 5, y is equal to 3/5 of x plus 4/5. So the gradient of that line is 3/5. So show that, arguably that would be enough, but then we say that 2 is greater than 3/5. Right, question 22. The triangles ABC and DEF are shown on the grid. Describe the single transformation that shows the triangles are congruent. Right. We could do it either way around. I'm going to go follow the process of the so A, B, C to D, E, F is a translation. Then if we pick a point, we'll pick this one. So we've got 2, 4, 6 across, 6 to the right, and 2, 4 up. So as a vector, that would be 6, 4. Right, question 23. Outside a cafe, there is a large plastic ice cream cornet. The cornet is in the shape of a hemisphere on top of a cone. The cone and the hemisphere have a radius of 24 centimeters. The cone has a perpendicular height of 117 centimeters. Work out the total volume of the cornet. Okay, so volume of a cone. Let's just sort this out slightly. So the radius of both shapes is 24, and then the height, perpendicular, the cone, so not the whole thing, the cone has a perpendicular height of 117. Right, work out the total volume. So the volume is going to be equal to the volume of a cone is 1/3 pi times 24 squared times by 117. To that, we want to add on the volume of the hemisphere, and it is a hemisphere, not a sphere. It's 2/3 of pi times by the radius, which is 24 cubed. So you don't need to do this. I could actually take 1/3 pi times 24 squared out as a factor and say that's going to leave us with 117 plus 2 lots of 24. Right, so let's type that in. So we've got 1/3 times by pi times by 24 squared times by 117 plus 2 times by 24. So that's going to be absolutely fine as my answer, I'm sure. 31,680 pi. But we will go decimal. It's going to be equal to 99,525.65527. I'm going to go 1 degree more accurate than the question, so I'll go to that point there. So we're going to go 99,525.7. Right, the actual cornets, the cafe cells are similar to the plastic ones. For the actual cornets, the cone and the hemisphere each have a radius of 2 centimeters. How many times greater is the volume of the plastic cone cornet than the actual cornet? Right, so our actual radius was 20. So real life and then the model is 24. So there's a scale factor there between the lengths of 12. So the scale factor between the volumes is going to be cubed. So the volume scale factor, the length scale factor equals 12. So the volume scale factor is going to be 12 cubed. So 12 cubed is 1728. So it's going to be 1728. Let's just check I've got that right. How many times greater? Yeah. Right, question 24. Here are the first four terms of a quadratic sequence. Work out an expression for the nth term of the sequence. Right, so I'm going to spread these out a little bit more. Right, the first set of differences then is 17. Second set of difference is 27. And third set of differences is 84 minus 47 is 37. Right, second set of differences then is 10. So that must mean that my sequence must start with half of that squared, so 5n squared. So 5n squared would give me 1 times by 5 would be 5, 4 times by 5 would be 20, 9 times by 5 would be 45, then 16 times 5 would give me 80. So let me write it. So this is our sequence. This is 5n squared. So we want to do, what do I need to do to the 5n squared to get to the sequence? So we need the difference to do what I need to do to this to get to this. So I'm going to do this, take away this. So minus 2, 0, 2, and 4. And then this has got a common difference of 2. So this sequence here must be 2n minus 4. So that would give me 2 minus 4 minus 2, 0, 2, and 4. So my total sequence is going to be 5n squared plus 2n minus 4. I'm going to double check that using my calculator table function, which is 9, I think. Yeah, so my first sequence, I just want to see whether this works. So 5 alpha x squared plus 2 lots of x minus 4. I want the first 4 sequence, don't need the second function. I want to start at 1 and I want to end at 4. But ending at 5 is fine. So that says that my first sequence should be 20, then, sorry, 3, then 20, then 47, then 84. So that's fine. So my sequence is 5n squared plus 2n minus 4. Okay, question 25 then. M is equal to P minus 2B all divided by 2. P is equal to 68.3, correct to 1 decimal place. B is equal to 8.7, correct to 1 decimal place. Work out the lower bound for M. Right, so for the lower bound, so we want the minimum value for this. So the way I'm going to do it is I'm going to say that the M min is going to be equal to the smallest possible value of P. So that would be P min minus 2 lots of PB maximum, so minus 2 lots of B max, and then I want to divide that by 2. Right, so I want the minimum value of P. So if it's been rounded to one decimal place, the minimum, so P min, is going to be equal to 68.25. And if I want the maximum value of B, so I'm going to call that B max, that's going to be equal to 88.75. So I'm just going to type it in like that then. So 68.25 minus, and actually I'll type it in as a fraction, minus 2 times by 8.75, and I want to divide that by 2. Let me check all my values before I press equals then. So 82.3, so minimum is 68.25. Yeah, that looks fine. And correct to one decimal place. The maximum value then would be that. So my final value then is going to be 25.375. 25.375. Question 26. On 3 days, Hedwig throws darts at a target. Here are his results. Monday, Tuesday, Wednesday, total. Work out the different estimates for the probability of... Work out two different estimates for the probability of Hedwig hitting the target. So I've got quite a few different estimates that I could use. What I'm going to do is the most accurate, which would be 54 over 90, which would be 54 divided by 90, which is 0.6. That's going to be the one I definitely use. And I'm going to take the most straightforward, and 15 over 20, which is 0.75. And realistically, I could have done, I also have the option of doing Tuesday or Wednesday. I could have done Monday and Tuesday. I could have done Monday, could have done Tuesday and Wednesday. I could have done any of those really. Which of your two estimates is a better estimate for the probability of Hedwig hitting the target? Give a reason for your answer. So 0.6. 0.6. That's it. Uses as it has more trials, as it has more trials. Right, question 27. Maneva and Remus travel the same 16.8 kilometer route. Maneva starts at 9 a.m. and walks at a constant speed of 6 kilometers per hour. And Remus starts at 9:30 and runs at a constant speed. Remus overtakes Maneva at 10:20 a.m. At what time does Remus finish the route? Okay, right, so I want to find out how far she's gone at that time. So the difference in time there is 1 hour and 20 minutes, which would be 1 1/3 of an hour after the start. So not the difference in time would be 1 hour and 20 minutes, which is 1 1/3 of an hour. If she's traveling at that speed, it means that she would have traveled 8 kilometers. When they meet, Remus would have run for 50 minutes, which would be 5/6 of an hour. So we need to work out Remus's speed. So his speed is equal to the distance that he's run, 8 divided by the time. The time would be 50 minutes, which would be 5/6 of an hour. So this will tell us his speed. So 8 divided by fraction 5/6. And we could treat it, yeah, that's fine. So that's his speed, 48 fifths. And then we want to find out the time that he takes running at that speed. So speed is equal to distance divided by time. We want his time, so the time will be equal to the distance, which would be 16.8 divided by his speed, which is 48 fifths. So the time that he takes is going to be 16.8 divided by my last answer, so 1.75. So that is 1 hour and 45 minutes. Right, so the time he started running was at 9:30. So if we add 45 minutes first of all, that would take us to 10:15 a.m. So I'm just saying I've added 45 minutes there. And then if I add on 1 hour, that would take us to 11:15. And we can do this using the time function on our calculator if we wanted to. We could do 9 hours and 30 minutes. And if I want to add to that 1.75 hours, 1.75 hours and 0 minutes, that would take us to 11:15. So we can use the time function if we wanted to. Right, question 28. A is a prime number, B is an even number, n is equal to a squared plus ab. Circle the correct statement about n. Okay. Okay, so for this, I'm going to do two trials. A is a prime number, so I think the difference that I would get is if I had the only even prime number, or 3. So I'm going to just do a quick trial with either of those, and let's say B is an even number, let's say 4. Let's just see what we would get for both of these. So if I do 2 squared, well, no, actually, I'm going to rephrase that to be A times by A plus B. So if we imagined it was 2 and 4 to start with, so an even times an even would be an even number. And if we imagined it being 3, 3 times by 3 plus that would be an odd plus times by an odd. It's just 3 times by 7. 3 times by 7, which is an odd. So it could be even or odd. We've just done a basic trial with 2 numbers, well, 2 pairs of numbers. Well, you understand what I've done there. Right, question 29. The function of x is 3x plus 9 over 5, and g of x is 6x minus 1. Show that g of f of 2 is an integer. Okay, right, so we're going to start by g of f of x. So g of f of 2 is going to be equal to, missed out bracket, we'll do it as g of, so if I put 2 in here, that would give me 3 times by 2 is 6. So 6 plus 9 over 15 over 5, which would give me g of 15 over 5, which would be 3. And then g of 3 is going to be equal to 6 times by 3 minus 1. So 6 times by 3 minus 1, which would give me 18 minus 1 would be 17, which is an integer. And part B, show that the inverse of 8 is not an integer. Right, so I'm going to work out the inverse first of all. The way I'm going to do that is I'm going to switch f of x and x over and then rearrange. So that would say then that x is equal to 3 f of x plus 9 over 5. And then if we rearrange that, that would be 5x minus 9 all over 3 is equal to f of x, or f to the minus 1 of x, sorry, f to the minus 1 of x. Right, so if we say that f to the minus 1 of 8 is going to be equal to 5 times by 8 minus 9 divided by 3, which would give us 40 minus 1, 31 over 3. And it's absolutely fine to leave it like that. Say 10 and a third, but I'm going to leave it as, which is not an integer. There you go, integer. Right, question 30. Circle the word that describes the graph of y is equal to sine of x. So that will be periodic. It repeats itself every 360 degrees. Okay, question 31. Shape A and shape B are on the grid. Describe the single transformation that maps shape A onto B. Okay, so I'm going to just join a couple of like points. There we go. So that's really what I need. So this is an enlargement, a negative enlargement. So this is an enlargement. Scale factor minus a half about the point 7, 4. Right, question 32. 61 students record how many hours they spent revising for a test. The histogram represents their results. So frequency, density, got our widths. Right, work out an estimate for the mean time for the 61 students spent revising. You may use your table to help. Okay, to do this, I first of all need to work out the frequency of each of the groups. To do that, I times the class width by the frequency density. So for this one, we've got 2, 4, 6. So it's going to be 6 times by 1.5. Gives us a frequency of 9. This one is 4 times by 3.5. 14. This one is 2 times by 5, which would give us 10. This one is 4 times by 4.5, which is 18. And then our final frequency is going to be 4 times by 2.5. Type that in wrong. So 10. Right, we're now going to look at the midpoints. So that's the middle of each group. So the midpoint of that group would be 3. The midpoint of that group would be 8. The midpoint of that group would be 11. The midpoint of this group would be 14. And the midpoint of this group would be 18. Right, for our estimate for the mean, we want to multiply these together, then add them up. So 9 times by 3 is going to give us 27. 14 times by 8 is going to give us 112. 10 times by 11 is going to give us 10. 18 times by 14 is going to give us 252. And then 10 times by 18 is going to give us 180. So we're going to those values together. We've already got that one in. So we've already got that one. So plus 180 plus 110 plus 112 plus 27 gives us a total of 684. So the mean is going to be equal to 681 divided by 61. So our estimate for the mean is 11.186 1811.1. That's I've written that wrong. 11.16393 dot dot dot. So I'm going to go 11.2. Right, part B. Give a reason why the answer to part A is an estimate because we use the mid values. Because I used the midpoints for each group. Right, question 33. A company makes two types of lampshades using fabric on wire frames. Lampshade A. The fabric is used to make the curved surface of the cylinder. The cylinder has a radius of 8 centimeters and a height of 22. Okay, lampshade B. The fabric is used to make 4 triangular faces of a pyramid. Each triangular face has a base of 15 and a perpendicular height of 24. Then we're given the cost of fabric. Okay. Work out the ratio of the cost of one lampshade A to the cost of one lampshade B, giving your answer in the form n to 1. Okay, so I'm going to do most of my working up here, just so I've got my picture next to me. So the fabric here is going to be equal to an area, and it's going to be equal to the area of a cylinder, which is going to be the circumference, which would be 2 pi r. And I'm going to times that by the height of the cylinder, so times by 22. So that's going to be 2 times by pi times by 8 times by 22. I'm going to leave it in terms of pi for now. So 2 times by 8 times by 22 is going to give me 352 pi. And lampshade B is going to be equal to 4 lots of half of the base, 15 times by 22. So that's going to be 2 lots of 50. So 2 times 15 times 22. That's 660. Let's type there, times by 24. 720. Right, so giving you answer in the form A n to 1. So I'm going to go A to B. First of all, I'm going to go for area. We said B was 720. And then we said that A was 252 pi. 252 pi, was that right? No, 325. Okay, and that is going to be our price for sorry, that's going to be our area for one lampshade in centimeters squared. Let me just double check that. Both for these centimeters and centimeters. Right, so 1 centimeter here. So let's say 1 meter squared is actually equal to 100 centimeter, 100 squared centimeters squared. So if this is the area in centimeters squared, I want the area in meters squared. So what I'm going to have to do is divide these by 100 squared. And that will give me my area for one lampshade in meters squared. So we'll do that. I'm a bit nervous about going decimal on this. That's my only issue. So I'm not actually going to go decimal. What I'm going to do is I'm going to carry on and say whatever this value is, to get the price, I'm then going to have to multiply by 400 for both of them, because that's the price of fabric per meter squared. And then that will give me the cost, but then to that value I need to add on £3. So I'll kind of leave that blank for now, but then I'm going to have to add on for the cost for A, £3.50, the cost for lampshade B, £7.50. So that will give me my total cost. I'm going to start with this one because I think that this one is slightly nicer. So if I do 720 divided by 100 squared, then times by 400, and then finally add £7.50, that will give me £36. Let's write that a bit better. £36.30. Right, and for the other one we've got 352 pi. And I want to divide that by 100 squared. Then I want to times that by 400. Then I want to add on £3.50. So that's going to give me 47.73 ... Then if I want that ratio as a 1, I need to divide this by £36.50. 36.3. So that's going to give me 1.314 ... And I'm going to go I'm just taking my decimals. So I've got this to two, well, it's two significant figures. So I'm going to go to, we'll go one more. So 1.31 to 1. So 1.31 to 1. Okay, question 34. A circle has a center of 0, 0 and passes through 0, 11. Write down the equation of the circle. So it passes through 11. So that's going to be x squared plus y squared is going to be equal to the radius squared. The radius is going to be 11, so 11 squared. And obviously, perfectly, that would be absolutely fine. You could also write x squared plus y squared equals 121. That would be also fine. Right, question 35. In a game, there are numbered tiles. These numbered tiles are in a bag. To play, choose a tile at random. Choose tiles at random, one at a time, and do not replace the tiles. You win if at any stage the total of the number on your tiles is 10. Ron plays the game once. Work out the probability that he wins. Right, let's think about ways that you could win. To win, W rather. So my options to win. So I could obviously go a 5 and then another 5. That would be one option. My other option would be a 5, 3, and a 2. That's my only way of winning. Just think. Oh, right. Okay. So there's only one. So in effect, we could do a 5, a 3, and a 2, a 5, a 2, and a 3. And then we're actually going to have six ways that we can make a 5, a 3, and a 2. Because if you think about it, 5, 2, 3, we could have 3, 5, 2, 5, 2, 3. Sorry, I'll list them all out. That's probably easiest. So I could do a 3, a 5, and a 2, a 3, a 2, and a 5, a 2, a 5, and a 3, or a 2, a 3, and a 5. So I've got 6 ways of making that, but each of those probabilities is actually going to be the same. Right, so the probability of picking a 5 and then a 5 is going to be, we've got 4 5s, haven't we? So we've got 4 over 8 times by 3 over 7, which would give us, we can do this without a calculator. Although, no, actually, I'm not going to cancel it down for the reason being it doesn't particularly matter, but I want to keep the denominators the same. So that will give me 12 of 56. Right, so my second problem, so that's a 5 and a 5. Right, then we're going to do any of these combinations. So let's say, let's go for this one. We'll work out this one first of all. Well, not first of all. We're going to say that probability of, and it doesn't really matter, 5, 3, and a 2 in any order is going to be equal to 6 lots of. Probability of rolling a 5, first of all, would be 4 out of 8. Probability of rolling a 3 the second time would be 2 out of 7. And then the probability of rolling a 1 would be, not a 1, a 2 would be 1 out of 6. My desire of keeping the denominators the same is a bit and actually it's not, because that and that would cancel. So that's going to be 8 out of 56. So when we add those two probabilities together, then so 12 out of 56 plus 8 out of 56, it's going to be equal to 20 out of 56, cancelled down by 8s, I think. Let's have a look. 20 out of 56. So 5 out of 14. So we've cancelled down by 4, not by 8. So 5 out of 14. Okay, question 36. All dimensions are in centimetres. Use Pythagoras' theorem to work out the exact value of x over y. Okay. So I'm going to work out the hypotenuse in terms of x to start with. So actually, I'm going to work out this length squared in terms of x. So I'm going to say that x squared, the way I'm going to do it is I'm going to say that 10y squared is going to be equal to x squared plus 7x squared. So that's going to give us 100y squared is going to be equal to x squared plus 49x squared. So that means then that 100y squared is going to be equal to 50x squared. So I'm going to rearrange this. I want x over y. So I'm going to actually start by x squared over y squared. So that's going to give me 2 is equal to x squared over y squared. Right, and if I square root both sides, because that's both sides squared, that would give me root 2 is equal to x over y. We could have plus or minus, but we're dealing with a length, so we can't really have a minus. So over y is going to be just root 2. Right, question 37. Lily has the following question for her homework. The net of a box is made by cutting 4 squares from a piece of cardboard. The cardboard is a rectangle with a width of x and a length of x plus 5, sorry. Each square has a side of length 10 centimeters. The area of the net is 1000 centimeters squared. Work out the value of x. Show that Lily can form the equation x squared plus 5x minus 1400 is equal to 0. Okay, so the total area of the square is going to be equal to x times by x plus 5. From that, we need to subtract 4 lots of 10 times 10, or 10 squared, and that's going to be equal to 1000. Right, so that's going to give me x squared plus 5x minus 400 is equal to 1000. And then if we take everything over to the left, that would give us x squared plus 5x minus 1400 is equal to 0, which is what she's got. The Lily correctly factorizes the equation to get this. Oh, that's nice. I thought they were going to ask us to factorize it. Her final answer for her homework is x is equal to minus 40 and x is equal to 35. Is her answer correct? No. I mean, if we think about it, the length of x can't be a negative number. So I'm going to say no. We can't have a negative length. So her answer is just 5 centimeters. And that brings us to the end of the paper. So before I sign it off, I'm just going to bring up the topic list and I mean rough grade boundaries. Okay, so this is the rough topic list because we've got a number of A's and B's. There's actually more questions than this, but these are the main topic areas that I was aiming to cover. It's quite a chunky paper. There are about 122 marks available for that. And based on students that sat this in the real exam, this was their grade. This is the average grade that they scored assigned to each of the grades. Sorry, average mark assigned to each of the grades. What I did was once I'd picked my questions, I arranged them by order based on grade 6 students. So aim behind that was to just make sure that the paper built in difficulty, just to make it a more realistic paper. And that's it. I hope you've done well on that. Just before I sign off, also, if you've found this very likely paper useful, there is a good chance paper also in the same playlist. Check that one out as well. If you found it useful, please do subscribe if you like. Thank you very much for your time in watching the video. See you soon.